Thank you very mumuch, Tobias, for having me here today, and thank you everyone for this wonderful meeting. I unfortunately only could arrive yesterday morning, but actually I had an amazing day, which was really noticeable because yesterday I had my first beer in, I think, 5 or 6 years, so it was a really, really good day. So, so I'd like to talk about our CCMI Doctor Training Center. So this is a joint doctor training center between UCL and Imperial College, and funded through the most recent EPSC call. And essentially, we are all about bringing together software engineering, software, compute, and data. That's really where we live. And the full title of the CDT is Collaborative Computation Modeling at the Interface. Now, there are few conclusions you can draw out of this title. First of all, we are really, really bad at including names. So, but the second thing is collaborative modeling and interface. So we really see ourselves as a CDT trying to bring together the communities in between research, software engineering, computation, and data, which traditionally are all having very different career PhD roles. And we don't think that's very healthy as we move forward. And so we want to try to establish a model of PhD training that pulls together what research software engineers are doing into the academic domains, back into the academic departments to get us through to the academic institution. So there's a bit of an overview of my talk, but let's get started. And unfortunately, sorry, you have to suffer through it, but I'm going to talk about myself a little bit. So, namely, agree on the facts. So, by the way, whenever you see pictures that really look like AI stuff, then you go ChatGPT. So, so in the first part, I'd like to talk a little bit about myself and where the motivation is coming from, because like many people here, I've done in my career, I've done lots of research software engineering, done other things. But in this kind of random gamble, when you do software, you become a research software engineer or in an academic department, the toying force threw me into the mathematics department. And that was very interesting. This shaped very much how I'm thinking about these things and what I would like to see as we're going forward. So let's just jump straight in. So first of all, I actually grew up in Hamburg, which has nothing to do with the talk. That's very nice anyway. What's actually more important is that so I'm a professor in mathematics department, but I didn't even study mathematics. I think by now my head of department knows. I think he has efficient. So, but I did study computational engineering at the Betcke University in Hamburg. So right at the time when I went to school, so the prejudice was always, I mean, I did like mathematics, but the prejudice was always, if you study mathematics, you become either a teacher or you go to an insurance. So by now, I know it's not true, but this was the prejudice. There were times that I thought, okay, I better study engineering. I'm not good at insurances. So, and so I decided to study computer science and engineering. And then I liked the whole high performance computing and numerical software aspects and all of this. I liked really, really much. So I actually decided to apply for PhD programs in numerical analysis, and I ended up on the Lecture Federal in the Oxford Computing Lab, which itself was kind of a funny construct because it was a numerical analysis, very mathematical, but inside the computer science department at the time. And by now they've actually moved to the mathematics department. So, but this was so for me, I actually do have a PhD in computer science, even though my PhD thesis is very mathematical. And then afterwards, I had a postdoc session in the usual postdoc run, Braunschweig, Manchester, Reading. Eventually ended up in 2011 at UCL. I had to admit the reason was my wife, she was already at UCL, so I had to follow my wife. So, and then a professor there since 2018 and since 2022, also academic fellow at the Advanced Research Computing Center. So, and why early on, I mean, we studied computer science. In my postdoc, I did very much. I did typically American mathematics paper. But over the years, I become more and more software oriented again. So back to the roots, essentially. And these days, I'm actually doing a lot of software work, and a lot of work on the interface of mathematics and research software engineering. And this is really important. And I want why this is important. This is actually slides, a bunch of slides I want to show you, which I actually did last week as part of my inaugural lectures. My inaugural lecture was 8 years late, thank you, COVID. And so I took the chance to give my inaugural lecture about the topic great numerical software and the mathematicians behind it. Because my mathematics department always had to justify actually doing software. They had enough of this, so I showed them lots of great software, and the mathematicians were actually doing this. So because my fundamental core belief is good software makes good science makes good software, so why do we actually distinguish? There's really no distinction. So, and obviously many of you know these examples, so I'm not going to go into details of them, but I mean, most of you have worked with Glass and LaTeX, and famous people behind this, obviously Jack Nagara, wonderful person, in general at Betcke, so, and all the great stuff that has come out of this. So I'm not, for this round, I'm not going too much into details of what the software is, because you know this. One of the best examples really is originally developed MATLAB, and I like to bring this in because I'm a big admirer of Timo. I met him a few times, then unfortunately passed away in May this year. So this big loss for the community. But he actually drove this as a mathematics professor at the end of the 1970s. He developed MATLAB and he became famous with MATLAB as a mathematician. So and it was actually him as a mathematician who brought us the whole area of interactive computing, research computing. And today we would say, oh, this is developing these kind of systems is what research software engineers are doing. We shouldn't distinguish between that anymore. So we should really come back the academic departments with this great work. Then obviously other great projects, Betcke, Shepard and others. I love to show this because obviously we won the 2015 science enterprise. And so wonderful example of a big collaborative project across lots of academic institutions involved, and the same way also DA2. Another wonderful project is mathematicians, computational sciences, many other people working together on a big software projects. And when we're having these big software projects, very often big chunks of those are research software engineers, and then you've got some mathematicians involved. But it's everybody's using them, and I'm pretty sure in the community example, you've seen this one, we actually also see examples where probably YouTube was somewhere in the background, but it's the people who are actually writing the software, they're very often not sitting in the academic departments. Not something we want to change. So, and the future really needs these fence sitters, which are not distinguished anymore. Am I a user in an academic department? Am I a developer, software developer? Am I a data scientist sitting in a data institute? And one of the positive examples I'd like to give is actually the Fusion Computing Lab, namely the aim of UKAEA to build a digital twin of whole fusion reactor project. So, and I love to bring this example because UKAEA is the great funder of our CPT. They're funding 2 PhD solutions for us each year, which is a wonderful contribution. But if you just think about the challenge of building the digital fusion reactor, obviously we need the data sciences, obviously we need the physicists, computational modelers, but obviously we also need the research software engineers, and not research software engineers as a professional service, but research software engineering as an academic discipline, on the same footing as the data sciences, computational modelers, and physicists, because the challenges in building a digital twin are so big that research software engineering going from the realm of the service to others to an academic research discipline as well. And that we should really proudly present and proudly say, no, we need all of these three together. I mean, actually need the people who can fluently move between the research software engineering, the data bit, and the computation sciences. And that's what our CPT is for. So at UCL, we have here in France Research Computing Center, many people here in NOAA and on corresponding parts of their own universities. But we are trying to address this with our ARC. What we're really trying to address is give research software engineers the same academic career path, the same academic possibilities as people in classical department. So our staff, the professional service contracts, have the same opportunities for promotions, same opportunities for grants, and with our CDT now, same opportunities for research supervision, PhD supervision as an academic department. We want to tear down these barriers. And that's really, really important. And it's important to tear down these barriers. So one little anecdote I want to give at this end of the introductory section is a couple of years ago. So I was talking to a colleague of mine who was head of department at another math department in the UK. And I've been knowing him well for many years. And he told me, yeah, Timo, with what you're doing today, this research software-oriented work in mathematics, every department would be happy to have you. But had you been doing this work at the beginning of your career, no mathematics department would have allowed it. And that's something that's wrong. That's something we need to follow. So, what's our CDT doing on this? So, we are trying with the CDT, we are trying to shape the next generation of students who are going through different careers. Some would like to do really more research software engineering focused careers, others would like to take the software into the academic departments, others will go to industry. That's all fine. We want to give them the option, but we want to train them in the sense of training professional research software engineers who are also great academic researchers in this. So, and this is the joint career training center between University and Imperial College. We've got over 30 million investment across UPSC, UCL, Imperial, and a bunch of partners. Later, we're going to be partners. At the moment, we've got funding to train over 70 PhD students. I'd love to achieve the number 80, so I cannot make my tax. I'd love to get over 80 at the end. So we're on a good way. So, and the important thing is actually led by ARC. And it was quite funny when we applied for the CDT. So, we actually tried in 2018 already, applied once with a very traditional CDT. And we made a computational sciences CDT. That's true. Mathematics department, we made it all the way through the interviews. And at the end, we were not funded. And obviously, it took me a couple of months constantly to get over this. But one important thing is about this, what we missed out from, we were not unique. Because we had a good training program, but it's a good training program that you could have also delivered at other universities, and we were beaten out by other universities. So this one counts in the American. So what we tried in 2023 then is we asked ourselves, okay, what actually can make us unique? And what can make us unique? So I started working together with ARC at UCL. We had this vision of driving forward research software on the academic background. And we said, okay, we've got a new department here, which is not a traditional academic department. It's people professional service contracts, but we're also doing academic work. So let's do something unique and use this to apply for CDT. So, and we had no idea how it would be received by the research council, but I'm standing here now, so it was not, was well liked. So I'm really, really happy that the PSCC took the gamble on us. So, but it's a very interesting challenge because I think we're the only CBT which is not led by an academic department. So, and I talk later a little bit about this, but that is the interesting factual challenge is also with universities. Anyway, let's talk about the CGT itself first. So we've got three pillars. We've got computation simulation, we've got research software engineering, we've got data sciences. So although I have to say that's one of the interesting things, whatever we do in computation simulations, we also make some more data sciences because students these days they want to do machine learning. So there are very few projects funded which are actually purely classical HPC without any data science, because students want something we need to be aware of, which is very much. Then our supported research, mathematical foundation, computation, scientific research, software engineering, and bridging the gap to applications. We see ourselves in the spirit of ARC as totally interdisciplinary. Yes, I'm from mathematics, but mathematics is not the key department here. Our students are actually spread out over 9 departments across UCL and Imperial. So we've got that Imperial, currently mathematics, computing, chemistry, aeronautics, and design engineering are joining us this year. And at UCL, we have mathematics, statistics, computer science, advanced research, computing, chemistry, and physical medicine. We almost would have had a PhD project in computational psychology this year, but unfortunately, the student at the end, last moment, took down the offer. But we are hoping to get something of that direction next year. And there are interesting things coming together. Sorry, in computational psychology, yes, they actually have wonderful data science computation modeling problems. So they fit in. So I'd love to support this. It's how do we get our students? Now that's the tricky part. We want students that are passionate about their vision, not just students with best transcript. So that's really important. In the first year, we actually had an application where students didn't have to submit a transcript at all. Got a lot of pushback from my academics on that. In the second year, we actually faced some pushback. They are now submitting a transcript, but the transcript is only a very small part of the overall shortlisting procedure. It's really just a fallback to check whether what we ask them to say about themselves in the self-description actually fits with the transcript. Okay. Students don't need to be expert coders, but they need to be willing to become one. And PDI is very much like the heart of our decision making, and that's challenging. It's really challenging, and unfortunately, we're going to front it up. So we've got a 3-stage process. We've got an online application interview, and then followed by a project matching phase. How does this look like? The online application, I always say the online application is super simple and quick to fill out, but then you look at these numbers and you say question 27, 28, 30, up to 34. All the 26 questions before are only statistical EDI monitoring and figuring out whether they're home or international students. So that's a mandatory part that every CDT has to do. The actual questions about the application itself is tell us about your academic professional background. Actually, half of the students we have been working before, which I'm really happy about. So you did not come directly from university. Select which aspirations best describe the types of field you want to do. That's actually not important for the decision whether we shortlist or not. It's just for us to see what kind of projects might they like later on. And then what aspect of the experience motivate you for these. But then the nice things, what aspects of CCMI PhD experience are you most looking forward to? What 3 things in career thus far are you most proud of and why? What interest, excites, or intrigues you most about creating project? And what's your favorite scientific nugget actually, and why? So if you're invited to the interview stage, please be prepared to discuss this. So my favorite scientific nugget is that we're closer in time to Cleopatra than Cleopatra was in the Great Pyramids, but no one mentioned that. So, but students could have any kind of scientific nugget. The reason why you're asking questions in this way has to be a little bit ChatGPT. They have to give all personal information about themselves. If the text appears generic and unpersonal, we just talk. Then they either haven't put in any kind of effort or they've used a large language model. Okay, so that's why we have this question that applies to them. And very important at the end, anything else they would like us to consider in terms of career challenges. Because when you have students with caring responsibilities or the EDI challenges, one has some level of mention at the start. Because if they are not shortlisted through the other questions, Can we have another look at them? Can we put them into the interviews? Okay. So students upload a transcript, but the transcript is evaluated separately. So all of this is anonymous. Transcript we cannot do anonymous, so that's evaluated separately. And it's only a small part of the assessment. So the interview, standard process, 2 interviews per panel. But what we ask the students to do, we actually, before each interview round, we select 3 papers and we give them the students as a choice and we ask them to give a short scientific presentation about one of the 3 papers. They don't know this area very much before they start. And we don't expect them to suddenly be expert in this. We just want to see, can they have a scientific conversation with us? That's the most important part of the interview. Would we like to have a nice scientific conversation with these students? And that's what we're really aiming for. So, and then after the interview, actually the hard work is starting. Because we are interviewing generically for the CBT. We don't care about what they want to do. We are just asking for the interview. Do they fit the CBT? Do they like the option? Okay. Then afterwards, we need to find a PhD project with them. We want them to have a PhD project before they start, so that when they arrive on day 1, they've got their PhD supervisor, they've got everything in place, and they can start on their research as well. So the way we do this is essentially speed dating. So the students from the interviews are invited for project matching, and then essentially it's a 2-week speed dating process in which they are given all the list of projects that they have. Typically it's over 50 projects across all the departments, lots of departments, and then they can contact the supervisors as much as they like and shop around as much as they like and have discussions. At the same time, we're also doing info events for them to explain them exactly what it means to be in specific departments and research is going to look like and so on. And then after 2 weeks, students are asked to submit preferred projects. And then we try to match this with the supervisors. We say, supervisors also in conversation with ideas saying, hey, are you two matching together? Was the speed dating exercise success? When it was a success, great, they're matched, you're creating a formal offer. If it wasn't a success, then the whole thing is complicated, because then we start engaging one-on-one discussions. Once you're put in, you want to have you really want to have you, you're having one-on-one discussion with the students, as long as it takes to find them a project. And with some students, it can take a long time and be a lot of discussions, but it's worth it. It's really worth it because we get to know them really, really well already in this interviewing stage. And that's actually a reason why very often they stick with us and are not moving over to other students. So we had in the second year, we had very few PhD students who turned down our offers, basically because we did a lot of one-on-one competition. And then, so once it's matched, they then get their formal offer for hyperuse in one period. That's a very time-intensive process, but it's quite important because you want to put together cohorts that are passionate about the overall thing and do not just only apply to us because they want to have a specific project with a specific supervisor. So that's very important. So gender balance. Now, gender balance is an issue. Big issue that we encountered in year 1, and we went into this very, very naively. In year 1, we thought, oh, we just do all anonymous selection procedure, and we're totally non-biased, it's all fine. No, sorry, doing anonymous selection procedures is very biased. So there's a problem when you have these kind of generic self-statement form. Women tend to be a lot more realistic than personal statement than men. So a lot of PhD students, they tend to be SO. So, and we actually, in a fully anonymous procedure, did bias that led in year 1 to the problem that suddenly, when we looked at statistical rates of who applied, generation of applications, and who we wanted to shortlist them for the interviews, there was suddenly a misalignment gap happening. We started looking at students' where this is coming from. Yes, it's the way they're writing statements. So in year 2, we were quite thoughtful to counter this. We actually looked at the EDI statistical data from who applied in the outline stage. And we then looked at the shortlisting. And then we did positive intervention in the shortlisting to make sure that we had the same gender ratio from the outline applications back into the interviews. We're not allowed to do positive action for the interviews in plan, but you are allowed to do positive action for this. And that's what we do to counter this possible. But that's something that we keep on and have to work on more in the future to get better. One of the ways in which we're trying to encourage more applications is outreach activities. So Imperial College has been running for years one of the fellowship schemes to Marius and McCann's Summer Research Fellowship. Mainly it supports women and undergraduate students in their final year to spend the summer within a research group that they're using in Imperial so that they get to know PhD level research. They're getting a very, very paid stipend for the summer and have lots and lots of other activities. And we already did from our CTP, we already had 12 such fellows we supported, and the next 6 they're actually starting just for next week, the next summer starting. And then also very importantly, supporting any Black heritage students on school at Imperial College, which targets but specifically to increase the number of PhD students with Black heritage background. So now they're in the CDTs. Okay, done. We just tell you become research software engineer now. That's fine. We think it works. No, unfortunately, it doesn't. We actually had to design a specific training for this. Well, not unfortunately, it was actually lots of fun. So there's an issue with this. We learned, so for a couple of years, we've been running at UCL, we've been running at MIT in scientific computing, which is led by the physics department. It's very interdisciplinary. They have involvement across mathematics, physics, computer science, and other departments. It's a wonderful MSc program. But students coming from Arkansas background, and once we put them in the mathematics lecture, half of them want to crucify us. So because they're not having mathematics there. So we were aware of the problem, and you have a very diverse cohort of students from very different backgrounds, from lots of different universities, from mathematics to chemical engineering, everything in their background. How do you actually design a teaching program for them? Yeah. At the end, we decided to do the brute force method. We just said, okay, we design everything ourselves. No more standard modules from the university. We just do a whole teaching program ourselves. It sounded really nice when you write this in the case of support. It sounds a bit more work than you actually have to do it because they're fun. So, and it was fun. Sorry. Thanks. Okay. Sorry, that's the part where I start getting really enthusiastic. So we have 7 training programs for the first 2 years: scientific computing, research software engineering, data-intensive computations, digitizations, deep learning, high-dimensional problems, and responsible computation modeling. Each training workshop is specifically designed for the CBD, okay, combining lecture-style content, student presentation, and software development. So how does this look like in practice? Here's, for example, the very first one, the programming models for scientific computing. We had, for example, on the Wednesday morning sessions, that was actually the workshop I was leading, introduction to dense and sparse linear algebra software. And then in the afternoon sessions, they had time to prepare for presentation. The next day, they actually had to give a presentation using these software packages, presentation on mathematical software libraries. And then in the afternoon, they had a hackathon where they had to do completely small projects on this. And then on the next day, we actually invited an external speaker, Chris Richards from Cambridge, talking to us on Phoenix and how they're using numerical software and actually developing numerical software. Okay, so and here's a selection of the kind of software applications did there, and that's very similar to how we organize all of these different workshop weeks. We don't just want to give them lectures. Lectures are just very tiny part, usually Monday mornings and Monday and Wednesday. Also, all the rest is just students' presentations, trying out software and talk about software software and research. And it's a lot of fun. We bribe them with a lot of cake, which is fine and works really well, but they tend to not just. Okay. Another example is deep learning, which was the last one which was running. Your colleague Martin Benning from CS, and he had done something really, really cool. So he had designed a challenge for the students, deep learning challenge, and then throughout the week they were looking at different techniques, and then whenever they learned one new techniques, they were implementing this in groups that were working against each other, and then trying to improve the learning systems, and then uploading this to GitHub. GitHub was evaluating this and automatically generating a leaderboard out of all of this. So they could see every day how they in competition with their peers, which they really, really liked a lot. It was a lot of fun. So that was, and that's something you cannot really do well in terms of traditional lectures. And traditional lectures are really not a good way to teach these kind of combined scientific software skills to students. So that's this part. But then I said at the beginning that they should all become really, really good research software engineers by the end. So, and to do this, we have something that we call a software journey. Yeah, our whole life is a journey. And the software journey is essentially the whole program that we designed around them learning to become active member of the research software engineering community. So they do work on ongoing software projects. We have once a term, so we've got, if you see in periods, we've got 3 terms every year. They're fortunately very well aligned, so otherwise it would be a problem. So we've got a term software for our students. We've got lots of talks by companies who are coming into us and work with us together on this. Okay. And let me just give you a couple of concrete examples. So here, the term software weeks themselves are mixtures of hackathons, software discussion, and external visits, and some highlights things that we've been doing with the students. For example, we had internal full-day sandwich to allocate new projects. Okay? We already prepare them for what it means to work later on with UKI and SLC. So be good at samples. So and they had to bring software ideas and convince other students and others to follow them. And not just them, it's actually us academics who also bring software ideas in the room. Okay? And one software VPA actually visited by Montreal, they spent a day with us to talk about AI hardware software, which is really, really cool. Another thing we had one software week was a one-day training workshop by AWS on agentic coding. You see a picture here. And then this was partially cool, partially scary for the research and systems are already. But we actually all learned a lot, and they're trying to work with us now to actually do a more sustained training program on agentic coding. Because one thing we noticed, we actually wrote our CDT case before the Cloud Code revolution. So we are trying to rectify this. Another thing is the ongoing software projects. We asked the students to, yes, you're writing your PhD thesis, but you also want to become an active member of the software community. You want to learn to write software. And so the only way to learn to write software is to actually write software. So we have these software projects that have been starting, that are progressing, and there's some really, really cool projects. I like to highlight here the Keynote project, Jupiter, but lighter, faster, and hotter, which is actually one of our students. She does a lot of plugin development for them in her spare time. And she started with a couple of friends in the CBT now developing a whole literary programming packages around data analytics, which is really, really cool. Obviously, these are my projects we'll see in a second. But we've got other wonderful projects, for example, manifold Markov chain multiple methods in Julia, led by Matt Graham in R, or actually one already completed project, data-driven covering of cosmology. So really, really cool things which are ongoing. So, and just to, so yesterday somebody asked me, Timo, you're not going to talk about Ross again tomorrow. And I just said, hey, hold my beer, I will talk about Ross. So, don't worry, not long, but this is just an example. So this is, we've got students working with this on the Ross project as well, one of many projects. And one student, just highlighting this right now, because he actually has just submitted a pull request to the Burn machine library framework to actually do a quick change to actually make it able to retain back propagation graph computation in other, which is really cool. A feature that PyTorch has, but this package didn't have yet, and he's currently working with the developers to bring this in. And I highlight this because it's so nice to actually, the students early on getting them, hey, just do a pull request for this, work with the developers, so they become active open source contributors. That's really important. Okay. Collaborations. We do have a bunch of partners. So I mentioned a bit, or I mentioned AWS, Kafka. So we have a whole bunch of other partners. All of them are really wonderful and important. I just want to mention directly UKAA because they are funding a lot of PhD research for us. And also STFC. STFC was actually funding in the first year an aligned studentship with us. And also in the second year, they're co-funding our studentship with us. So which is really wonderful. And they're having more and more discussion with STFC about collaborating working together with them. So especially with the STFC right of people in scientific. So and then lots of other great partners that we have. This is just a snapshot. The partners is constantly moving in. You get new companies in, sometimes the companies leaving, because the contact person you had there is leaving. So it's just, this is really just a snapshot. Okay, so here is just in terms of things we do. Partners we had recently, a couple of weeks ago, there was when I was at 34 degrees in London. What did we decide to do? Obviously, on that day, a 3-hour train trip to the Diamond facilities and visit Diamond in 34 degrees. It was an amazing day. I should say hard to do. So so we spent the whole day with the CDT there, and they had the whole day discussion on software projects. And really good, really productive, and was amazing to hear them and hear having a very productive exchange in our portfolio of operations on software. So how to engage? So if you want to engage with us, it's actually not difficult. Easiest thing, talk to us about collaborative software projects. Our students love doing software. They're really good at doing it. So co-funding of studentships. So full studentship is around 140K, but we have all kinds of co-contribution models. So typically partners from half studentship, sometimes we do fund a full studentship. If you are using a peer advisor, simply talk to us to advertise relevant projects. Very simple. However, just advertising project doesn't guarantee your students. So you actually put in some work because lots of other people are advertising. So you have to sell ourselves to get the students. And then come and visit us in our company. That's something we love to do. And we are constantly asking people to come along, talk to our students, and spend a day with us. Show them how it is to be a professional research software engineer and work on some really good projects. Are we AI yet? Well, my second AI slot picture, sorry, I didn't use such a slide. We actually wrote CDT proposal before cloud code. Almost all our students obviously have AI. So you see, it's not yet paying for this. Lots of discussion about what to do about all of this, probably. But most use coding agents. We've done one agentic coding workshop so far, but we do have discussion on this. And I just wanted to say headache, but it's not really a headache. It's a super interesting challenge. Because, for example, when we talk to AWS today, they have no idea how to train people in agentic coding. And they ask us how to train people in agentic coding, so we have no idea either. And so we're actually working with our partners right now. What does it mean to be a research software engineer or a software engineer in general in the age of agentic coding? Which skills should they actually teach? That's an ongoing process. We do not yet have the answer, but we do have the capacity to experiment. That's what we do. So a bunch of final thoughts. What actually works? A lot. So it's fun. So the students across the 2 universities and 9 departments code and collaborate together. We often see when we have interdisciplinary proposals, interdisciplinary consortium arrangements, and so on. First question is, can those people actually talk together on these different disciplines? So the students don't have to shine a stick. They just do it. So, and that's really good. No matter which department they really don't care. They sit together, work together, and go together, and it works really good. So we have extremely good application numbers. So a lot of doctoral training programs today have problems finding enough home student numbers. But we don't. We've got very strong home student numbers, so including very strong home student numbers. And that's good for community because it means a lot of interest out there. A lot of students, they want to learn about how to actually they want to do a PhD on the extension area between AI, software, science. They love this. They want to do this, we need to do this. And also, a lot of good ability is to make a CBT work that is set by a non-academic department. There are all kinds of funny challenges. For example, we couldn't register any of the students in ARC because ARC is not registered on the teaching system of academic departments. So CS, computer science, stepped in and all students are now registered through computer science. And all of these interesting challenges, which we suddenly encountered at the start, it somehow worked out. Okay? Cost us a few speed was nice, but a lot of people at the universities to make this work. And that's good. That's really good, and that's what needs to happen because we need to loosen these barriers between academic and non-academic departments. They don't make sense for all members of the departments. So, but obviously there are quite a few challenges. So, software projects. So we do have a bunch of software projects students are doing, and supervisors behind this. We tell students who want to advertise for other students, you need to give your students time to do other work. We insist on this, and there's a problem. But we do not yet have, so far, with a single cohort, second cohort starting soon. We need more critical amount of students to actually go the project bigger than 1 month. That's coming. So we want multi-cohort approaches to projects. So that, for example, the students from 2 cohorts working together, 3 cohorts working together in a project, teaching out the coding together. That's developing. That's going to develop. Already talked the gender balance. The topic actually we took in year 2 in terms of the open application space are better than year 1. That's not yet there where we want it to be. And I said that a lot of goodwill was there this year to make this whole thing happen. But when a lot of goodwill is necessary, it means that there are a lot of barriers that need to be overcome because otherwise the goodwill wouldn't be necessary. And we still have institutional and cultural challenges. I mean, from just registering research software engineers as PhD advisors, theory they can, but then in practice, getting these through the faculty approval boards and all these kind of things, that's just one of the many challenges we still need to overcome because there's still professors who think, oh, academic departments, they should have the only part to do this, not the non. So that's something we're still working on fighting on. And that's a lot of administrative headache in the back. Student voices. I hope this works on me. When we tried to talk, sometimes I hope the videos are working with sound now. I was a little bit mean. We had our CDT showcase last week, and Imperial was paying for the ad course, so that was very nice. And so after the students had a couple of things, I went around with the video camera and talked about the CDT. So let me just, I should have tested this something. I just.
Okay, I guess we believe it's elaborate relevant. It's been great to work along a lot of different students from different kind of departments and work on big problems. So one of the projects I'm working on is manifold NCMC. We have students from supplied by art, chemistry, and maths. And we've all come together to build a package of Junior. Having never written in Junior before, it's been quite an eye-opener. And seeing 2.9 personally manifolds are also.
That was, I'm sorry for the something at the end. I don't know what happened there. Next is Sky. Sky is a student. She was the one doing the wonderful work with Venus and the project.
Hi, I'm Sky from CCMI. I like CCMI because, well, I mean, like, because it's a mixture of the research and the software engineering. So I'm really enjoying getting to do like numerical research, but also having like a number of projects on the side that I get to work on and see develop into actual programs.
and Charlotte. So Charlotte is one student in the division of medicine, which is really great that we also have met.
CCMI, what don't have it. I love the freedom to be able to read this whenever I want. So for example, today, I was doing some work on my primary topic, but I did a deep dive into Gaussian processes. And in doing a deep dive into Gaussian processes, I did a deep dive into kernels. And so I revised a lot of stuff about kernels, and then realized, oh, it's actually a really interesting way of thinking about just the structure of functions and why they'd be important. You're thinking about how to model something. And then I started thinking about why would you ever use supervised learning if you could just use Gaussian process to try and estimate a function? And I'm still thinking about that now. And the CCMI answer to that.
I should tell the BBC whenever you do Voxbox, do it part. So to the end, just the only thing that remains is to thank a lot of people. So first of all, our leadership team. We do have a very big team. I'm just one part in a big team of people. And Colin Potter, Tony, Laura, our director of planning operations, really on the side. Matthew Sproggs, who's from ARC, is leading the day-to-day teaching and training. It's really amazing. We've got our co-directors, research partnerships, admissions, training. So a lot of people are actually making this happen. Not just here. One great thing actually about us being in ARC is much better in professional service support than academic ARC, because most of the people in ARC are professional service people and prisons. And they're actually much better at doing this kind of thing than the kind of stuff you usually have to make up of problems. That makes a lot of things a lot easier for us. And finally, I'd like to thank all our year one students who actually took the gamble with us and jumped on board with us, enjoying being really much with them. Thank you.